During this lesson, we are going to look at the Traffic Collision and Avoidance System, TCAS, which is also known as the Airborne Collision Avoidance System, ACAS. We will look at the equipment required, how it is operated, the indications, and action to be taken in the event of a traffic advisory or a resolution advisory.
Descend.
TCAS does not guarantee a specific separation from other aeroplanes, but does inform crews of traffic in the vicinity of their aeroplane and gives vertical vectors to avoid other contacts. It does this by adapting the transponder system to not only reply to ground radar interrogation, but also to other aeroplanes. For TCAS to see another aeroplane, it must have at least a Mode Alpha transponder fitted. Without that, TCAS is blind to other traffic. With Mode Alpha, you get range and bearing information. In addition, Mode Charlie gives height information. So let's take a closer look at the equipment fitted in the aeroplane. The transponder is a transmitter, receiver and computer in one combined unit. For the system to transmit and receive, we require aerials which are fitted to the top and bottom of the aeroplane fuselage. In addition, with version 7 of TCAS 2, which is the ICAO standard system, we also incorporate Mode S, which incorporates a discrete data link between aeroplanes. We obviously need a control panel to input the Mode Alpha frequency, turn the system on, select the range, and select Resolution Advisories off, as in certain situations the aeroplane will not have the performance to carry out the vertical maneuvers the system might demand. We also require a means of displaying the traffic seen by the system. This can take the form of a dedicated display, or it can be incorporated into the vertical speed indicator, the navigation display, or the primary flight display. Now look at how TCAS works and the indications presented to the crew. TCAS works on the secondary radar principle using the normal transponder frequencies of 1030 and 1090 MHz and can deal with numerous threats at the same time. Using this principle, it creates two protective three-dimensional bubbles around the aircraft, labelled TA and RA on the diagram. These are based on the time to reach the closest point of contact, which is called a TOR. The limit time is different depending on aircraft altitude, which is linked to a sensitivity level, and the planned separation value is between 300 and 600 feet, increasing to 700 feet above flight level 420. If any aeroplane enters the first bubble, then a traffic advisory is displayed to the crew in the form of an amber circle. In this example, the target aeroplane is depicted as -04, which is 400 feet below. As well as the visual warning, a verbal warning is also given, as this is a potential collision threat.
Traffic.
If the aeroplane continues on this track and enters the second bubble, then a resolution advisory is generated. The symbol changes from an amber circle to a red square, and either a preventative advisory or a corrective advisory is issued in the vertical plane, instructing you to climb or descend. A preventative advisory is where no risk of collision exists unless either aeroplane changes its vertical profile. In this case, the instruction is to monitor vertical speed.
Monitor vertical speed.
A corrective advisory is where a collision risk exists and a maneuver is necessary to avert it.
Descend.
The limitation of the system is that the aeroplanes could be given similar avoidance actions, and collision may not be avoided. So with version 7 of TCAS 2, Mode S was introduced, which is a discrete data transfer between the aeroplanes and ensures that they are given different vertical instructions. As well as traffic and resolution advisories, the system also displays other traffic and proximate traffic. Other traffic represents transponder-equipped aircraft within the selected range and in a relative height band of plus or minus 2,700 feet, and is indicated by a hollow cyan diamond. Proximate traffic is traffic within 6 nautical miles and within a height range of plus or minus 1,200 feet, and displayed by a solid cyan diamond. The symbols used on this particular example are +10 and an up arrow. This shows a contact 1,000 feet above and climbing at a rate of 500 feet per minute or more. The least reliable information displayed from TCAS is the bearing, so crews should not try to interpret tracks or anticipate the system, as they could make the situation worse. This is why all resolution advisories are given in the vertical plane. Occasionally, a target can be displayed without bearing information. These are displayed at the bottom of the screen, and up to 2 targets can be displayed in this way. The first figure is the range to the contact in nautical miles, and the second the height, including minus for below and plus for above, and the arrow signifying a climb or a descent of 500 feet per minute or more.
Increase climb. Increase climb.
So far, for simplicity, we have shown the TCAS information on the vertical speed indicator, but on most aeroplanes the contact information is displayed on the main navigation display. The climb descent resolution advisory information is displayed on the primary flight display vertical speed scale using a red band. In this example, the system is demanding a descent rate in excess of 1,500 feet per minute. There are times when the aircraft is not going to be able to follow a full resolution advisory, and so there are various inputs into the system which restricts TCAS resolution advisories. An input from the radio altimeter restricts resolution advisories from issuing the increased descent instruction below 1,450 feet. At 1,000 feet, no resolution advisories are produced, and below 400 feet, no traffic advisories are produced. Where the aircraft's performance is limited, that is at height, or with gear or flaps deployed, climb and increase climb resolution advisories are inhibited. On receipt of a traffic advisory, crew should try to locate the target aeroplane and be prepared to respond to a resolution advisory if the situation changes. If the aircraft cannot be located and gives further cause for concern, then crew should seek advice from air traffic control.
Traffic, 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 traffic.
If TCAS issues a resolution re-advisory, crews are required to respond to the TCAS command immediately. Resolution re-advisories override ATC instructions. During the maneuver, crew should inform air traffic of their actions by using the TCAS instruction. For example, TCAS climb or TCAS descent.
Climb, climb.
On completion of a TCAS maneuver, the aeroplane should be returned to its assigned flight level, and air traffic should be informed of this. From this lesson, you know what the components of a typical TCAS system are, how TCAS is operated, and the indications associated with the system. You also learned under what circumstances the TCAS system would be inhibited, and the actions required from a crew during traffic and resolution advisories.
Climb, climb.